Good afternoon, everyone. Welcome to my YouTube channel. Please comment, share, and subscribe. So, my name is Teacher Jumai Lula, and today's lesson we are going to cover RCL circuit. So, in this RCL circuit, we are going to cover calculations, the difference between series circuit and RCL parallel circuit, and also how we define RCL circuit and others. So please guys, let's start. Let's check the first step. It says RCL. So what do you understand about RCL? RCL is an electronic circuit consisting of resistor, inductor, and capacitor. So which these components can be either connected in parallel and series. And in parallel series, the current can flow in one direction which pass through a component sequentially. So but in parallel, only voltage will share only voltage, the total voltage won't split. The one which gonna split will be current, which flowing through all components simultaneously. So then the next slide it says, or it shows the capacitor, inductor, and resistor. So the first one there, as you can see, we have a capacitor, which is used to store what electrical energy temporarily. The second one is an inductor, which is an magnetic. It creates magnetic when an electric current is passed through them, then which are also commonly used coil-like structure in electronic circuits that are mostly used to reduce or control electric spikes in a circuit. The fifth one is what? It's a resistor. You all know what resistor mean according to physical sense or Kirchhoff's. So this resistor will slow down the electric current in a circuit. It slows the flow of current in a circuit. So now we are going straight to the difference between parallel and RCL series circuit. What do you understand about the two of them? Let's go to the next page. The next page it shows series circuit. So series circuit is an it has the resistor, inductor, and capacitor which are connected in one path, as you can see on the diagram. Then, so the same voltage flows through all components. So the voltage from resistor, inductor, and capacitor, I mean like current, will be the same. Then each component it affect what current differently. Which resistor opposes the current flow. Then the inductor it also create magnetic opposition. The third one, which is capacitor, it releases charge or store capacitor. So in all, they are going to do what? They're going to form AC current, which is called impedance. Right, let's go to what parallel circuit has for us. So when we go straight to parallel circuit, it says my side on my parallel circuit, I have resistor, inductor, and capacitor, which are connected in separate branches. You all know that a parallel circuit has separate branches, right? Which uses same voltage supply. So the voltage in each component is the same as you hear the statement, then but the current in each will divide. right? So these RCL circuit are commonly used in filtering or power distribution system, which are mainly used on power systems there. So now, for the sake of the time, we are going straight to our series calculations. So here is the statement. It says in a series RCL circuit containing a resistance of 12 ohms, an inductor of 0.15, and a capacitor of 100 are connected in series across a 100 voltage and 50 hertz supply. Then question it says calculate the total circuit impedance, the current of the circuit, and the power factor. So what's the next step? So since we know that the formula of a total impedance of the circuit can be written as what? As a impedance 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 equals to resistor squared plus into what? Into include all in circuit. So but we only have resistor here. We don't have this one, don't have this one, right? So for us to be able to calculate them, we're gonna use this formula, which says a resonant inductor equals to 2 pi times frequency times then we say 2 pi our given frequency is 50 and times what? Times 0.15. So this one it matches with this one here. Then we are going to say this and this is equals to 47.13 ohms. Then next one we calculate our capacitor inductance, which says resonance, which says 1 divided by 2 pi frequency. Then you see 1 divided by 2 pi into 50 times 0 times 100, which is going to give us 1 divided by 2 into 50. Then the answer here is 31.8 ohms. Don't forget to write ohms. Then when we come this side, we are going to say the root divided by into what? 47.13 minus 31.8 squared. Include them in one bracket. So our total impedance will be so punch your calculators for practice purpose. Then tell me what you have did. Your answer supposed to be Your answer supposed to be 19,47 ohms. Then the second question says calculate the circuit current. Circuit current is given by total current of the circuit is given by what? The total voltage of the circuit divided by total impedance, total total inductance, which is okay. Then we're gonna say 100 divided by 47,13. Then 100 divided by 47,13, which is gonna give us 2,12 ampere. The third one is power factor. Power factor will be cos power factor. We are going to say, let me write it on the top there. Power factor is PV equal to cos of theta. Then it's equals to cos of what? Cos of our R is 12 divided by impedance, which is 19,47. Therefore, our impedance will be 12 divided by 19,47 to give us 0,61 leaking. So when we move further to our parallel, we are going to say so on that one, 1 kilo resistor and 142 mAh coil and 160 capacitor are all connected in parallel across the whole. So the formula to calculate impedance is going to be impedance equals to 1 over R squared plus into 1 over X minus 1 over. So then all squared. So we only have resistor. So this resistor, it is given in 1K, which is 1 times 1000 to give us 1000 ohms. 1000 ohms. Then the second one we have lactancy, which is 142 divided by 100 to give divided by 1000 to give us what? To give us 0,142. Okay, so for us to calculate this, we're going to say equals to 2 pi f L, which is 2 pi. Our frequency is 60. Our frequency is 60 divided times what? Times 0,142. 10 2 into what? Into 60. I'm sure you're punching with me. Then 0,142 to give us 53,53. The second one is this one, give us 1 over